Question 3 says the graph of y has a vertical asymptote and a removable discontinuity. What is the value of a? So we want to figure out what this number a has to be so that this quadratic factors in such a way that we find one removable discontinuity and one vertical asymptote. So the first thing that I'm going to do is I'm going to write the denominator as factors. Now, the only thing that could possibly cancel out of this equation is x minus 5. It's the only thing in the numerator. So I'm going to factor this quadratic into x minus 5 times x minus some unknown value c. So if I were to FOIL this quadratic out, 5 times c would end up equaling a. That will indeed cancel our x minus 5. And we can say that x equals 5 is a removable discontinuity. So remember here, you have to show in your work that you have found both of the things, the conditions that were set in the problem. So this simply leaves us with 1 over x minus c. So I have to figure out what c is. Now, the denominator we started with, which is x squared minus 7x plus a, has to equal x minus 5 times x minus c, right? Because this denominator has to be the same as this denominator. Now, if I FOIL out these two terms, I'll get x squared. That's the first two terms. The outside terms are minus x times c. The inside terms are minus 5 times x. And the last two terms are plus 5c. I'm going to combine like terms. So we have x squared minus c plus 5 times x plus 5c. So now what I can do is I have a quadratic equaling a quadratic, and I can kind of compare like terms to figure out what numbers I want to look for. So my coefficient of x squared and x squared match up, so we're okay there. In order for these two things to be equal, we need 7 to equal c plus 5. So 7 equals c plus 5, which shows us that c must equal 2. And then we also need to make sure that a and 5c are equivalent. So a must equal 5c. So a is going to equal 5 times 2, which is 10. And so a is what we were looking for. And so a equals 10 is the correct answer. Now, we could also, if we were really doing our due diligence here, we could see that if we set up the limit as x approached c from the right of 1 over x minus c, this would in fact come out to be infinity, and c is a vertical asymptote. So if we really wanted to be diligent, we could say, look, we don't even have to know the value of c to see that if you're coming at c from the right here, that this would be a little bit bigger, you get a positive number. So we have found that this graph does have a removable discontinuity and a vertical asymptote, and we figured out what value of a would be needed to factor into those two things.